problem with an unusual looking constant here. It's based on a fairly simple idea. We're talking about a cubed root. So it's just based on the familiar property that if you have, let's say, a raised to the 3k times b as your radicand raised to the 3, let's call it I, is just equal to a to the k b raised to the I power. And of course, we're assuming that k and I are integers, positive integers. Where n is the positive integers. Okay, so this simple idea, it's just, this is two operands or factors here, but this extends to multiple, of course. Okay, so we're saying let n be the smallest positive integer such that the cube root of that smallest positive integer times 13 factorial is a member of the positive integers. Now, this is kind of unusual right here. It's based on a direct calculation, but show that this expression is less than 750,000, 3/4 of a million. Now, again, fairly routine. You write down the definition of 13 factorial, and then just as an example, where do we get this 2 raised to the 10th? Well, you have a 2 right here, 2 to the first power. 4 right here is 2 squared. So far we have 3 copies of 3. Here's 2 times 3. Here's 2 cubed, 3 of them. Okay, so how many do we have so far? 3, 4, 6, 7. Okay, we get another one right here to up our count to 8. And then we get, what is it, 2 squared times 3 right here. So you can count all those 2's, and there's 10 of them, okay? And you would carry on in a similar fashion to find 3 to the 5th, 5 squared, 7, 11, and 13. So again, not an Olympiad level problem at all. It's fairly routine, in fact. By inspection, to create multiples of 3, you would have to multiply by this value of n. No need to write down its Hindu Arabic representation. N has to equal to this in order to create multiples of 3. 12 is a multiple of 3, 6 is a multiple of 3, all the way across, right? Okay, so right now it's very self-evident just by inspection that the cube root of n times 13 factorial is equal to this expression. Now, how do we show without a calculator that this is less than 750,000? Well, this calculation right here is fairly easy. This is 16 times 9, which is 144 times 5. So this part right here would be 720. Okay, just these first 3 factors, which 16 times 9 is 144, and 5 times 144 is 720. Now right here, here's the fun one. In fact, this next one is actually a fairly famous constant as far as recreational math goes. This is 7 times 143. Okay, but this has the nice property, if you choose to call it that, of being equal to 720 times 1001. Now that's a wonderfully simple constant to work with respect to multiplication, because you're going to create 720,000 plus another copy of 720. So this is equal to 720. 720. And again, you can see why this would be a fun recreational constant. Okay, now, but that is, of course, less than 750,000. So again, we whiz through this without a calculator, not even coming close to needing a calculator to confirm this. And of course, this I'm not sure how even big this is. You know, if the cube root of it, well, you could look at, here's the number, 2 to the 12th, 36, 5 cubed, all right? But this is just some massively large number. We never had to even have come to grips with its magnitude. We just used laws of exponents. Very nice. So anyway, we're QED time. We have proved what we set out to prove without a calculator. Thanks for viewing.